Hi students, in this video we will be learning a very important form of equation of the line, that is normal form of equation of the line. This is a very important derivation from straight lines chapter, that is normal form of equation of the line. Now let us understand the statement of the theorem, then we will understand the proof of the theorem. As per the blueprint of the Karnataka PU board exam, it is very clearly specified that a 5-marker question appears from the chapter straight lines, and the two a derivation will generally appear from the straight lines chapter. It can be to find the perpendicular distance or the normal form. So in that sense, this is a very important derivation. In part D of the question paper, you will be able to find 5-marker from the straight lines chapter. For any theorem, you may find different proofs for that, but it's always recommended to write the proof given in the NCERT textbooks. You have to follow that proof only, and when you have to write it in the exam, make sure you're writing the same proof prescribed by NCERT textbook. Okay, now let us understand the statement of the theorem. An equation of a non-vertical straight line L. There is a non-vertical line. What do you mean by that non-vertical line? That is, it is not parallel to y-axis. Simple. Okay. There is a non-vertical line L such that length of the perpendicular from the line to origin. That is, if you draw a line which will be perpendicular to the considered line L, and that line joins to the origin, and that perpendicular line makes an inclination of alpha with a positive direction of x-axis, then the equation of the line would be x cos alpha plus y sin alpha is equal to p. And what is this p? This p is the perpendicular distance of the line to the origin. Let us understand this with the help of diagram. We are considering a rectangular coordinate system. Okay, and this is the line L. So this equation x cos alpha plus y sin alpha is equal to p is the equation of this line L. Okay, now length of the perpendicular from the origin to line L is p. That is, for the line L, if you draw a perpendicular and you join that perpendicular to origin, then that length is p. That is what is given. So this distance or the shortest distance from the line to origin is p. That is what is the meaning. And alpha is the inclination of this perpendicular, and this is a perpendicular line, or this is a normal to line L, and this perpendicular or this normal makes an angle of alpha with the positive direction of x-axis. It is making an angle alpha with the positive direction of x-axis. If we know these two things, then we can find the equation of the line. And that equation of the line is x cos alpha plus y sin alpha is equal to p. So understand the statement of the theorem. This is the equation of the line that we are finding. And what information we know is of this normal, not of this line. Understand? We know the information about this line. This normal makes an angle of alpha with the positive direction of x-axis. It is not this line L which is making an angle alpha. It is the normal to the line L is making an alpha with the positive direction of x-axis, and its distance from the line to origin is known. Then we can find the equation of the line. See, from origin to this point, if you consider, is also a distance from line to origin. From origin to this point is also a distance from the line to origin. But which is the shortest distance? It is this perpendicular distance is the shortest distance from origin to the line L. Is it clear? So whenever I say this line, perpendicular line, you understand that it is a normal to line L. Normal is a line which is perpendicular to the considered line. Okay. So that is why the name normal form. When you know the information on the perpendicular line, you can find the equation of the line L. So that is what you have to understand here. I am calling this point as A. That is point of intersection of this normal and the line L. And this perpendicular distance, that is this length of the normal from the line to origin is P. As per the data, I am calling this as P. That is OA as P. Now let us consider any arbitrary point on the line P of x comma y. Now I am dropping a perpendicular from A to x-axis. So this will be M. What is this AM? AM is the height or y coordinate of this point, correct? Yes, this is the height and this is the y coordinate of this point A. Now, what are the things known to us? Length of the perpendicular or length of the normal from the origin to the line is P. This is what is known to us. This is the line of which we have to find the equation, and this length is what we know as P. And this normal makes an angle alpha with the positive direction of x-axis. This is the information we know. This information is of the normal, not of the line L. So this is an arbitrary point. Now I am considering triangle AOM. Are you checking this? Yes, we are considering triangle AOM. Now this is the height, correct? This perpendicular, that is y coordinate of this point. And what do you think this is? OM. OM is x coordinate of the point A, correct? Yes. Since this is a right angled triangle, we can consider sine alpha. And what is sine alpha? Opposite by adjacent, right? That is perpendicular by hypotenuse. You can also say this. So, AM by OA, correct? AM by OA is nothing but sine alpha. And we already know OA as P. So, we are substituting that. So, sine alpha is equal to AM by P, which we can rewrite as AM is equal to P sine alpha. What did we find now? We found AM. We have found the y coordinate of the point A. In the next step, you will understand what are we actually trying to find. So, we have found AM, that is y coordinate of the point P. Now we shall find the x coordinate of the point P. X coordinate of the point P is OM, right? We shall find that. If I take cos alpha, then this is adjacent by hypotenuse, right? Cos alpha is adjacent by hypotenuse or base by hypotenuse. If you understand from this, it will be OM by OA. OM by OA is cos alpha. So we already know OA as P. So cos alpha is equal to OM by P. So OM is equal to P cos alpha. Now we have found the x coordinate of the point A, correct? So this x coordinate is P cos alpha and this y coordinate is P sin alpha. So what we have just found is the coordinates of the point A. So for x coordinate we can write it as P cos alpha and for y coordinate we can write it as P sin alpha. We have found a point on the line L. We had no information about the line L. We did not know slope, we did not know a point on the line, but now we have found a point on the line, that is coordinates of the point A as P cos alpha comma P sin alpha. So if we just know the slope of the line L, it is easy for us to find the equation of the line. We have found a point on the line. Now we are going to find the slope of the line. How do we do that? Let me call slope of the perpendicular or slope of the normal OA as M1. And what is that? Tan alpha, right? Because we know the inclination of OA or we know the inclination of alpha. So its slope will be tan alpha. Now I'm calling the slope of line L as M2, and from the data we know that these two lines are perpendicular to each other. OA is normal to line L. So you know a very important condition. What is that condition? If any two lines are perpendicular to each other, then product of their slopes will be equal to -1. This is a very important condition which you already know. So I am going to use this concept to find the slope of the line L. So slope of the line L, M2 will be equal to -1 by M1. Because we already know the slope of M1, so we can write this as -1 by tan alpha. The point that we have just found is in terms of sin alpha and cos alpha. So I am writing this tan alpha as sin alpha by cos alpha. When cos alpha goes to numerator, slope of line L, that is M2, will be equal to minus cos alpha by sin alpha. So what is the slope of the line L? It is minus cos alpha by sin alpha. And we also know a point on the line. Now we know slope of the line L and a point on the line L. Now it is easy for us to find the equation of the line, correct? We had no information about the line. Using the data of the normal, we have found the slope and a point on the line L. So using point slope form of a line. This is a very important form of equation of the line. Dear students, you have to memorize this form using point slope form of the line, that is y minus y1 is equal to m into x minus x1. Using this, we can find the equation of the line. How? We have found the slope of the line L and a point on the line L, and we can substitute that here to get the equation of the line. So we shall do it now. So m is minus cos alpha by sin alpha, and x1 y1 is equal to p cos alpha comma p sin alpha. So when we substitute, y minus y1 is equal to y minus y1. y1 is p sin alpha. So it will be y minus p sin alpha equal to slope is minus cos alpha by sin alpha into x minus x1, x minus p cos alpha. We have substituted slope and x1 by 1. Now we shall cross multiply sin alpha to LHS. That gives us y sin alpha minus p sin square alpha, because we already had sin alpha here. So the term becomes p sin square alpha, and minus cos alpha into x gives us minus x cos alpha, and this negative becomes a positive. Then there is a cos alpha here and a cos alpha. So it is p cos square alpha. Now we'll group the terms in such a way that sin square alpha and cos square alpha are together, sin alpha and cos alpha are together. So I'm moving this term to LHS and this term to RHS. That would be x cos alpha plus y sin alpha is equal to, there is p which is common to both the terms. I'm taking that out as common. So that is equal to p into sin square alpha plus cos square alpha. You already know this basic standard form, that is sin square theta plus cos square theta is equal to 1 for all theta. So this term will be 1, which gives us the equation as x cos alpha plus y sin alpha is equal to p. Equation of the line having normal distance p. Normal distance is shortest distance or perpendicular distance p from the origin to the line, and angle alpha as the inclination with a positive direction of x-axis, which the normal makes. Then the equation of the line is x cos alpha plus y sin alpha is equal to p. Dear students, I hope you have understood the whole proof. Now I will do a quick recap just to make you understand what was given and what we actually did. There is a line L of which we have to find the equation, and there is no data about this line L, but there is a normal from this line to origin, that is a perpendicular from this line to origin of length p units. This perpendicular distance is p units, and this perpendicular is making an angle alpha with the positive direction of x-axis. Using these two information, we are finding the equation of the line L. Correct? Understood? Information is of the normal, but we are finding the equation of the line. So just to find the equation of the line, first we will find a point on the line L. We will also find the slope of the line L using the data of the normal. First we will find a point on the line L, that is we will find this point A, the coordinates of this point A. We will drop a perpendicular, then this is a right angle triangle and this is alpha. We already know that. We will consider sin alpha to get this height, that is y coordinate. We will consider cos alpha to get this OM, which is the x coordinate of this point A. So after we have found the coordinates of point A, then we will find the slope of the line L. How do we do that? From data we know that these two are perpendicular lines, and we'll use the concept that if any two lines are perpendicular, then product of their slopes will be equal to -1. Using that concept, we will find the slope of the line L, and we will write this is in terms of sine and cos only because our point A has the coordinates in terms of cos alpha and sin alpha. Understood? So after finding the slope and a point on the line, we are using the point slope form of equation of the line. When a point on the line and slope of the line is known to us, we can find the equation of the line. This is the standard form. We have used that. We have substituted in the standard form, and on simplification, we have got the equation of the line as x cos alpha plus y sin alpha is equal to p. Now, what this alpha and p are of the normal. Please remember that this is the perpendicular distance or normal distance or shortest distance. Please understand that this is the shortest distance and this is the angle of inclination by the normal with the positive direction of x-axis. If you understand this theorem and if you learn this theorem, any sum on this can be easily solved. You can easily identify the form of equation of the line that is to be used. Hope the concept is clear now. If you still have any doubt, please do mention it in the comment section.